Just a minute, sir. I'll just join now. So wait, one minute.
Subtopic of rotational motion. Okay. So what is actually rolling motion? In the beginning of the chapter, we have discussed about combined translation plus rotation is called rolling motion. And there is a term called pure rolling motion. Okay. That is rolling without slipping. Rolling without here there will be rolling but not pure rolling. It will have slipping also along with rotation plus translation. Like example, so when your tire is stuck in the mud, can you imagine there? It rotates more than it slides, isn't it?
Yes, sir.
The translation motion will be less, but rotation motion will be more. Sometimes when you apply the brakes, instead of the tire, more slides than rotates, right?
Yes, sir. Yes.
So there's the two kinds of rolling, but they're not pure rolling.
Okay.
Pure rolling is like simply just there will not be any slipping. There will not be any.
Okay. Slipping.
Did you understand this point? Without any slipping in a sense.
Yes, sir.
So sometimes in this rolling motion, translation motion will be higher than rotational motion. Sometimes rotation is higher than translation motion. But in pure rolling, there is no slipping at all. Okay.
Okay, sir.
Or like an example, you can see, suppose just tire gets rotated. Simply, there's enough friction. There's no brakes applied. There's no sliding, and there's no mud where more rotation is happening, right?
Yes, sir.
Example, you can see one example. Suppose if you take a tire of this sort, if you keep, if you tie a thread from here, okay,
Okay.
entirely, if you here there is loose ends, okay. When the tire moves slowly, when it comes here, actually the entire rope will be connected to the road, okay. That suppose there will be a rim wherein you tied a rope to the rim and you're making that rim move, so then that rope will be coming onto the ground, right?
Yes, sir.
Now if you see an example of this pure rolling, now there will be translation which is due to the center of mass. Whatever the motion the center of mass is moving, that is called as translation, and it is rotating about the center of mass also, right? Like this. So when one circle completely completed, one from here to again, when it comes to here, this point A, when it comes to that again A point, what will happen? It will travel a distance of 2 pi r. Got it?
Yes, sir.
Translation will happen by a distance of 2 pi r. This is the length of the rope that is here, and there is one rotation is completed there. Exactly one rotation completed here. The center of mass travel to a distance of 2 pi r. Did you get this point?
Yes, sir.
This is a scenario of pure rolling, okay, where there is no slipping happening.
Okay.
This impure rolling mostly will
That
not.
means there's no friction. No.
Friction should be required. Friction, if friction is not there, it will generally slide. Only that friction will provide the torque so that it can rotate about the center of mass axis. Okay.
Okay. Yes, sir.
Without friction, it cannot rotate only.
Yeah, of course.
So that's why I told you pulley. We consider the pulley to be frictionless, massless, and
Ideal.
if it is having friction, it will rotate also, that pulley.
Okay.
Otherwise, it will slide. That's it. Because that friction is providing the torque, that point, so it will rotate about that point. Okay.
Yes, sir.
Here, velocity of center of mass represents translatory motion. Because with center of mass, entire body is also going. So that center of mass represents the linear motion of the body, that is translatory motion. Okay.
Yes,
Then
sir.
angular velocity about the axis, because it has an angular velocity also, right? About this
Yes.
point, center axis. Angular velocity about the central axis will represent rotational motion. Okay.
Yes, sir.
Then how can we say that it is pure? How can we say that? Pure. I told you it is not slipping is happening. Okay. So for it to not slip means what?
Yes, sir.
Carefully understand your point. Try to understand the point. It is not slipping means, suppose when do we say these two hands are there, these two hands are slipping. When one hand is having a relative velocity with respect to the other hand or not. In friction we studied about this point.
Yes, sir. Yes, sir.
Either this should slip or
The other thing should
arm
slip.
should slip. Otherwise, if they are not slipping means exactly they are not having any relative velocity, right?
Yes, sir.
That means note point is
They need to be relative.
relatively rest. Okay. If the
Okay.
relative velocity of the point of contact of the rolling body relative velocity of the point of contact of the rolling body with the surface is zero. Relative velocity is zero. I'm not saying velocities are zero.
Yes, sir.
Then it is known as, then it is pure rolling. Okay. That velocity, generally directly the formulas are given for you, but I'll try to make you ensure. Suppose there is a body of this sort. This can be disc, cylinder, and anything. We'll discuss about what if it is a sphere, what if it is a disc, what is if it is a ring, what if it is a hollow sphere, hollow sphere, what if it is a hollow cylinder, what is if it is a solid cylinder. We can see all those scenarios later on. Like I'm taking a rotating body, for example. Okay, here it's now. What I want to say is I'm considering this velocity of this center as velocity of center of mass. Okay.
Yes, sir.
First thing I fixed is this is translating with center of mass velocity. Second, what I will consider is I will assume that this entire body is rotating about the center. Okay.
Okay, sir.
What I am doing is two parts. One thing is part entire body is going with velocity of center of mass, right?
Yes, sir.
Because the wheel is moving, right?
Yes, sir.
Second, what I'll consider is I'll fix this center of mass. Maybe the center of mass is moving. I'm going in to sit in the center of mass and observe. The actually all particles are rotating also, right? Right.
Yes, sir.
So if I consider any particle on this body, with how much velocity it is rotating, how much speed if it is rotating, so r omega, isn't it? I'm fixing this axis and observing. Got it?
Yes, sir.
R omega. If this point is there, R1 omega. If this point is there, capital R omega. Point is this R2 omega. Like that, depending on the radius, the speed of the particle will change at a given point. Got it? Because
Yes, sir.
I can assume this entire disk or ring, whatever it may be, it is moving in circles about this point, right?
Yes, sir.
So combined this part is called as, both combined called as rolling. For pure rolling motion, for pure rolling motion, carefully you need to understand. So in general, first equation can be written as like this. So at any point, what is the velocity? Suppose this entire disk is also moving, like it's like, I'll tell you. If you're sitting here, okay? If you're sitting here, how much velocity you will go forward? Tell me. It's like you are in train. You're in train, okay, or you're in boat, okay?
Okay.
Boat is going with 3 meters per second forward, and in boat you are running with 2 meters per second forward. So what is your velocity actually? Tell me.
It'll be 5, sir.
5 meters
Backward.
with respect to ground, right?
Because
Because boat is also moving. In that boat, you are also moving. So you automatically will have boat velocity 3 meters per second.
yes, sir.
With that, you will already you are having an extra 2 meters per second with respect to boat. Got it?
Okay. Yes, sir.
So now nothing but the velocity of u with respect to boat is equal to velocity of u minus velocity of boat, right?
Yes, sir.
Velocity of u is equal to what? Velocity of boat plus velocity of u with respect to boat, right?
Yes, sir.
Which is
5.
5 plus 3. So similarly, here the particle will have velocity of the center of mass plus velocity of this particle with respect to center of mass. Are you getting this?
Yes, sir.
Velocity of this particle with respect to center of mass is what? This r omega, right?
Yes, sir.
Point. So to in vector form, if you want to write, velocity of this particle is velocity of the center of mass plus omega cross r. You know that velocity is equal to omega cross r. Okay. Otherwise, omega r sin theta. Here the sin theta is actually 90. In magnitude, it will be omega r. Got it? R omega.
Yes, sir.
General scenarios. So did you understand this one?
Yes, sir.
Now, both if we combine, that will be the point. Now, you see here, if it is traveling on the ground, many cases, generally many examples, as far as mains and NEET exam is concerned, what will happen is, this floor will be at rest. But in advanced and some kind of tough mains questions, this floor also will be moving.
Okay.
You need to carefully understand. So when the body is pure rolling on this floor, and mostly 99.99% according to your syllabus, questions will be coming from pure rolling only. Okay.
Okay.
But in HC Verma, there are 2 questions, just MCQs asked regarding that slipping, where translation is higher, rotation is lower, where rotation is higher, translation is lower. There are 2 objective questions that I'll send you. MCQs, okay.
Okay, sir.
That is only 2 or 3 questions left, but generally all the questions according to the syllabus should come from pure rolling. In
Okay.
pure rolling, this particle, whatever that is in touch, it should not relatively slip, right? It should not have relative velocity. If ground is at rest, this particle should also be at what?
Yes, sir. 1 minute.
It should be at rest, right? Now, this particle will have a, suppose if it is having radius r omega speed in left side direction, right? Rotating
Yes.
in clockwise if it is, okay?
Yes, sir. Yes, sir. Understand.
But this particle will also be having v center of mass, because the entire body is going with center of mass, right? In forward direction. So now for it to be
Yes,
at,
sir.
the velocity should be net velocity should be what? 0, right?
Yes, sir.
That means v center of mass should be equal to.
V R omega.
That is why in pure rolling, but every time it is not r omega. You need to understand,
Okay.
because if this will have velocity or not, we need to check. When the ground is at rest, so we can have this kind of situation. Okay.
Understood, sir. Okay, when ground is not at rest, then we need to consider velocity also.
Then what we need to write? Velocity of center of mass minus r omega is equal to velocity of the ground. Got it? If ground is
Yes,
going
sir.
in forward direction,
Yes, sir.
then velocity of velocity of center of mass is equal to velocity of the ground plus r omega. Got it? Okay. Did you get
Yes,
it?
sir.
Okay. Now keep it.
Yes, sir.
Now velocity of center of mass is r omega. Now there are 3 points because generally there are a lot of other points, but in mains and NEET, mostly they will discuss about 3 or 4 points. One point is this point, topmost point. One point is bottommost point. One point is this point. One other point is this point. Anywhere between also they can ask. Okay.
Okay.
VE velocity will become how much? VE velocity will become, this will have r omega. V center of mass is also in the same direction, right?
Yes, sir.
That is V center of mass plus r omega. That is equal to what? V center of mass plus V center of mass, right? Because r omega is V center of mass, magnitude. So 2V center of mass. The top
Yes, sir.
point will have 2 times of velocity of center of mass.
Huh.
Otherwise, you can also write it as 2 times of r omega. Got it?
Yes, sir.
Velocity of this bottommost point will be 0. Okay. That is why they will consider instantaneous axis of rotation. Because generally what? Axis will be at rest, remaining particles are all rotating right about that point.
Yes, sir.
At that instant, this particle is actually moving now. It will actually touch the ground, go. Touch the ground and go. When it is touching the ground, it is at rest. That's what I want to say. Instantaneously, that particle will be at rest. Got it?
Yes, sir.
That is why sometimes this V point is considered as instantaneous axis of rotation.
Okay.
Because generally in rotation, pure rotation, not rolling, sorry. In pure rotation is what? Fan, you see. That axis will be,
Yes.
fan will be,
It is fixed.
pure rotation is what, isn't it?
Yes, sir.
I gave an example of cycle stand. You keep it on, you keep it on stand and you try to pedal the cycle, then it will purely rotate about that axis, right?
Axis will not move. Yes,
That means the axis
sir.
is
Yes,
at
I
rest. That is
understood.
a pure rotation case. About center of mass, if you want to observe, this is pure rolling case because it is rotating also, it is translating also.
Okay.
But
Understood.
about this point, which point? B point, which is instantaneously at rest, that is having pure rotation. Got it?
Yes, sir.
B point is instantaneous. But that B point is not translating, like that we'll take.
Okay.
Instantaneous axis of rotation. Got it? Then what is the velocity of C point and D point? You see here, C point will have velocity like this, D point will have velocity like this. That means what?
Yes.
So if you see, D point will have a resultant velocity like this because V center of mass will be like this, R omega will be like this. So the answer,
Yes, sir.
root 2, it will be having root over V square plus V square, root 2V center of mass. BC point also will have root 2V center of mass, but direction will be different for both of them, right? Okay.
Yes, sir.
Any point like that we can find out if you know the angle. If you know the angle, what can we do is, suppose any other point, if you consider, suppose if it traveled a theta angle, this point, topmost point, if you want to find out the velocity of the particle at this point, velocity, magnitude is, we can find out. First velocity is what? So it will have a velocity, if this is theta, this is 90. So what will happen? This,
90 minus theta.
this is theta. This will be theta, right?
Which one, sir? Okay. Yes, sir.
Isn't it? Because this is theta means this is 90 minus theta. This is 90 minus
Yes,
theta.
sir. Yes, sir.
90 minus theta. This will become theta, right?
Uh-huh.
Now, this has having velocity and this will having r omega, right? Translate velocity of the center of mass, right?
Yes, sir.
This actually in magnitude of v is equal to r
Yes, sir.
omega. Now, what is the resultant velocity at that point? Root over v square plus r omega whole square plus V is r omega whole square can be written as V square also, right? Root over V square plus 2
Hmm.
V square cos of theta, angle between them. That is 2V cos theta
Cos 90. Okay, cos theta.
by 2 is the resultant velocity of a particle at the given point. If it has covered theta from here, when theta is
Yes,
equal
sir.
to 0, the answer will be 2V. Theta is equal to 0 means the particle is exactly at this point.
Okay.
Because cos 0 is 1, 2V is
One.
the 2V center of mass.
Yes, sir.
This formula you can use at any general point theta. Okay.
Yes, sir.
Then coming to rolling kinetic energy. Rolling kinetic energy is, so it will have both translational plus rotational, because what we are considering is about it is translating entire that body, so it will have a, all the particle will have a translational energy, right? That is half into m into v center of mass square, right?
Yes,
Plus,
sir.
if you fix this point, every particle is rotating also, right?
Yes, sir.
So it will have a pure rotational energy about this fixed axis, right? This axis.
Yes, sir.
So
Okay. Yes, sir.
translation energy plus rotational energy about the given axis, right?
Yes, sir.
Rotating about that axis, that will be rotational energy is half I omega square. Got
Yes,
it?
sir. Yes, sir.
But if you want to write about this point, that is instantaneous axis of rotation, you don't need to write translatory because we are considering that particle is at rest, right?
Yes, sir.
So we'll write like this. So this is a translational energy and this is a rotational kinetic energy. This is translational kinetic. Why is rotational kinetic energy? So you see, if suppose some axis is there, simply I'll derive this formula. So as a side derivation, you don't make it in the main derivation. Suppose if an axis is there, if some particles are rotating, right, like this. So every particle will have a
Yes,
velocity.
sir.
So half into mv1 square is the energy, half into m into v2 square is the energy, half into m1 m1 v1 square, m2 v2 square, m3 v3 square is energy, right? So on, n particle.
Yes, sir.
But half into m1 into v1 is what? R1 omega whole square, right?
Omega. Yes, sir.
M2 is R2 omega,
R2 omega whole square.
because everything will have same omega about the point. This we have discussed.
Yes, sir.
It will cover equal angle for all the particles moving in the circle about that given axis, right? M3 R3
Yes, sir.
R3 square omega square, so on. So if we take here half m1 r1 square will be sorry, half will be common, omega square will be common, but m1 r1 square plus m2 r2 square plus m3 r3 square, so on, right? Right?
Yes, sir.
What is m1 r1 square plus m2?
Yes, sir.
This is nothing but moment of inertia formula, right? Of this,
Yes, sir.
that is half
I
omega square. So that
I
is
omega square. Yes.
energy.
Understood.
Otherwise, half mv square formula relevantly we can write half is half I moment of inertia. Instead of mass, we will have moment of inertia here. Instead of velocity, we will have
Velocity,
angular velocity.
angular velocity. Yes, sir.
These two are the energies. If we try to solve the problem, half into mv square plus I can be written as mk square, right? As radius of
Yes.
this I thought.
Right.
Omega can be written as v is equal to r omega. Omega can be written as v by r. Can I write it as v square by r square? So this, if half mv square is taken as common, that is v center of mass square, 1 plus k square by r square will be the total rolling kinetic energy. Okay. This is an important formula. Make it 5 star. Got it?
Yes, sir.
Now there will be ratios can be asked. Suppose energy translation is to energy rotation is to energy total energy. The translation energy is what? Half into mb square. Rotational energy is what? Half into I
Half
omega.
into I omega
What?
square.
Mk square.
Okay.
Omega square is uh,
V
v
square
square
by
by
R
r.
square.
Okay. Is half into total energy is what? Adding up, that is half into
Both rotational and
k square
translated.
by r square, right? The derivation we did above.
Yes, sir.
Now half mb square, half mb square, half mb square can get cancelled. The answer will be 1 is to k square by r square is to 1 plus k square by r square. So, depending on the body, you can write the ratios.
Yes, sir.
Translational by rotational means 1 by k square by r square. If someone asks you what is the amount of translational ratio of translational energy, kinetic energy to rotational kinetic energy means, what you will write here? 1 by k square by r square. E translational by E rotational. That will be r square by k square. Got it?
Yes, sir.
Question is asked as E translation by E total energy. What is the part of? What is the ratio of the translational to total energy? If that kind of questions is asked, 1 by 1 plus k square by r square.
R square, yes.
R square by r square by r square plus k square. Like that rotational to total, like that rotation, like that any ratio can be asked in exam. Okay, this is one of the.
Yes, sir.
Then what you can do is all these ratios you can find out for different bodies. That bodies you can take it as homework, but I'll just paste the result here. But you can try solving it for all the bodies, applying ring, disc, solid sphere and all. Okay.
Yes, sir. Okay, sir.
I just sent you the image.
Okay. Yes, sir, I got.
You can practice that. Just I'll try to paste it here so that whoever is like listening to the recording can go through it and pause it and just.
Okay.
I'll just try to paste it here. Just you can practice there.
Okay, sir.
This is another diagram, but any question can be solved. Just I'll try to take one of the question here. Solid sphere or
Okay.
spherical also we can take. What is the solid sphere radius of gyration? Mk square is equal to 2 by 5 mr square, right?
3.
So that will cancel. K will be root 2 by 5 r. Now the question is, if I try to calculate rotational by total, I'll try to calculate three of them. One is, what is k square by r square? So if I take from directly from here, k square by r square
Yes, sir.
is equal to how much? 2 by 5 r,
1.
r square. That will be 2 by
Okay, yeah.
5.
By 2 by 5 plus 1. 2 by 7. Yes, sir.
Translational by rotational is what? 1 by k square by r square.
Yes, sir.
That we have already discussed in just above.
Yes, sir.
Rotation is 1 by k square by r square, that is r square by k square. Because out of
Understood.
k square by r square, if we reverse it, what will be happening? 5 by
5
2.
by 2.
So the questions will be asked like this. So what is the ratio of the translational kinetic energy to rotational kinetic energy? That will be 5:2.
Yes, sir.
Suppose
Understood.
the question is given as uh, this is what translational to rotational, right? Suppose if question is given as rotational kinetic energy is 30 joules. What is this? What will be the
Yes,
translational question will be asked like this.
okay, 1 minute, sir. I'll tell.
You can solve the problem. I'll try to help you out whenever these kind of things are there. What you can do is you consider like this. There are many other ways of solving. If you consider that is what 2, right? Denominator.
Yes. Yes, sir.
So 2 for two parts. For two parts, what is the amount of kinetic energy? Question is asked. What did I give? Rotational I gave, right?
Yes, sir.
For two parts, that is how much energy? 30 joules. Got it? For 5 parts,
Yes, sir.
how much will be the answer? 5 into 30 by 2. That will be 250 answer. 5 15s are how much? 75 joules. Got it?
Yes, sir.
But there's other way of doing it also. Not other way, but there's some shortcuts to these ratios and all. I'll tell you whenever the time comes, okay? Whenever
Okay, sir.
a lot of questions are asked on these shortcuts. Tough
Okay.
questions. So this 5 by 2 is the translation to rotational ratio. Similarly, so what we can do is 5 parts is translational energy here, 2 parts is rotational energy. If what is the ratio of translational to total? That is what? Translational is 5 parts, total is 5 plus 2 is 7 parts. Got it?
7. Yes, sir.
Otherwise, you can solve by the formula that I taught you just in previous hand.
I understood, sir. This one.
Rotational to total. Rotational is how many parts here? 2.
2.
Total is 7. 2 by 7. Got it?
Yes, sir.
Like that, you can solve spherical cell, solid cylinder, hollow cylinder. All these diagrams, you can try solving them. In exam, any kind of question can be asked. Just okay.
Yes, sir.
Then, shall we go ahead?
Yes, sir. Okay, fine.
Is there any doubt?
No, sir. I understood.
So suppose angular momentum. What did I teach you? Angular momentum is equal to R cross P, right?
Yes, sir.
Here,
After perpendicular.
suppose if the body is pure rolling, if some point angular momentum is asked, how will you write? First, you need to understand what is the angular momentum for the center of mass about any point that you are asked, okay?
Okay.
Angular momentum of the required point will be equal to angular momentum of center of mass plus angular momentum of that point with respect to center of mass. Got it? Got it?
Yes, sir.
This velocity is what? R cross, radius cross mass into velocity of that particle, right?
Yes, sir.
So that particle will be velocity of center of mass only in magnitude. Got it? So then
Yes, sir.
this will be what? Angular momentum of the center of mass. That is, first whenever we want to find out a particle, what will we do? We'll find out the particle angular momentum about center of mass. That is this one. Then we'll try to find out what is the angular momentum of the center of mass with respect to the point that we want to find out. If we add both of them, we'll get the angular momentum of the particle. Got it?
Yes, sir. Yes, sir. Understood.
Then now the important part of it is more important. Rolling motion about an inclined plane. Rolling motion about an plane. How to solve this inclined plane? Okay. Questions will be asked like this. Now it is pure rolling is happening. Solid cylinder is there, hollow cylinder is there, otherwise solid sphere is there, hollow sphere, anything can be given. So then they might ask you what is a generally mostly to BITSAT or NEET, medical entrance exams or many other MSET or any engineering exams, the question will be asked mostly like this. Rather than the exact values, they'll ask you the comparisons. Comparisons means a solid cylinder is there, hollow cylinder is there, ring is there, which will actually reach the bottommost point first. They all are released at the same point, same inclined plane. Okay.
Yes, sir.
They might ask you this one, which has highest rotational energy at the bottom point, or which has highest translation energy at the bottom point, which has highest speed at the bottommost point, velocity of center of mass. So these kind of questions when we asked. Okay. What is the acceleration of the three bodies? Comparison. Which acceleration is higher? Like this?
Yes, sir.
Okay. Shall we solve them? Okay. First thing is,
Yes,
it
sir.
should have enough friction. It should have enough friction, otherwise pure rolling will not happen. Got it?
Yes, sir.
Second part is, whatever the potential energy is here, that will be converted into total kinetic energy, right? Both translational and rotational, because it is pure rolling. So suppose if I consider this as height h, this I consider as s. Here if we want to write down what is sine theta is equal to h by s, isn't it?
Yes, sir.
In terms of s also question might be asked, in terms of h also they can be asked, in terms of theta also question can be asked. Okay. Now for this body, the potential energy is converted into total kinetic energy, that is mgh when it reaches the bottommost point is equal to half into mv square into 1 plus k square by r square. Got it?
Yes, sir.
M cancel. So velocity is equal to, that velocity is nothing but root 2gh divided by, generally we'll get root 2gh if single particle is coming. But if because it is rotating, the velocity will be root 2gh by 1 plus k square by r square. Got it?
Yes, sir.
This is nothing but velocity of center of mass. That's what, right?
Yes, sir. Understood.
We took it in the previous picture. This is important point. Then sometimes question can be anything, because h cannot be, may be given or may not be given. If h is given, it is okay. H is not given, h is equal to what? S sin theta, right?
Yes, sir.
T is equal to root over 2g s sin theta divided by 1 plus k square by r square. Got it?
Yes, sir.
Simply the body slides means the simple case that we have discussed in particle Newton's law.
Newton's laws of motion.
That is k square by r square is 0. There is no rotational energy there.
Root 2gh.
Root 2gh or root 2gs sin theta.
Yes, sir. V is equal to root 2 GS sin theta.
That's the simple answer. That is why you see, because here denominator is higher, velocity while sliding should be greater than velocity while rolling, because the entire energy is not converted into translational energy. It is also some part of energy is converted into rotation of the body. So then velocity of the sliding should be greater than velocity of the rolling. Here purely entire part is converted into translational energy, but here some part is converted into rotational energy also. That is a velocity when it reaches the bottommost point during pure sliding is greater than velocity while it is rolling. Got it?
Yes, sir.
Then acceleration. How acceleration will be there? V square is equal to, I am considering only center of mass and I am trying to solve it. V square is equal to U square plus 2as. So final velocity is U is 0 initially. Final velocity is 2gh or 2gh by 1 plus k square by r square is equal to 2 into a into s. So s is also can be written as h. H is s sin theta. S can be written as h by sin theta. H by sin theta. H can be cancelled. The answer will be 2 can be cancelled. So g sin theta by 1 plus k square by r square. So if these formulas you need to know to find out which has acceleration, higher acceleration, lower acceleration, which has a higher velocity while reaching the bottom point. Okay. This
Yes,
is
sir.
same and all. But one point here we'll consider from the given scenario, from topmost point and all. For velocity also 1 plus k square by r square is coming denominator. For acceleration also 1 plus k square by r square is coming denominator, right?
Yes, sir.
For three different bodies, velocity is inversely proportional to k square by r square, right? Can I say? Inversely not, that means not directly inverse, but the more the ratio of k square by r square, the lesser the speed will be there, right?
Yes, sir.
Okay. If three bodies are given to you, solid sphere, hollow sphere, or any solid cylinder, this kind of questions, what you need to do? You need to figure out k square by r square. Which has higher k square by r square, that will have lower velocity. Got it?
Yes, sir.
Which has higher k square by r square, that will have lower acceleration. Got it?
Yes,
Okay.
sir.
Already, if we take it as a particle, k square by r square is 0, acceleration is equal to g sin theta. That is what we studied in Newton's laws of motion. Got it?
Yes, sir.
You remember that g sin theta acceleration in Newton's laws of
Yes,
motion?
sir. A is equal to G sin theta, I remember.
Another part is time taken. Time taken is what? S is equal to half into at square. Initially velocity is 0. T is equal to, translation I am taking 2s by a. So that is what? Root over 2s by g sin theta 1 plus k square by r square. Okay. This can be converted into,
Yes, sir.
this can be converted into, s can be converted into h by sin theta, right?
Yes, sir.
If you convert 2h by g sin theta, can I bring it outside? So 1 by
Yes, sir.
sin theta into 2h by g into 1 plus k square by r square. Do you remember what 2h by g? Time.
Yes, sir. T is equal to root 2h by G, I remember.
2h by g into 1 plus k square by r square is there here. If k
Yeah.
square by r square is there, that means if rotational component is higher, so what will happen? Time will be higher. It will take more time to come down.
Okay. Yes, sir.
That means reverse. Velocity will be highest if k square by r square is lowest. Acceleration will be highest if k square by r square is lowest. So if acceleration and velocity are highest, it will come very quickly. That means time is the lowest. Got it?
Yes, sir.
Time is low for low if k square by r square is low. If time is high, time taken will be high if k square by r square is high. That's what I want to say. Okay.
Yes, sir.
So like that we can draw some notification here. Are you writing the notes? Then
Yes, sir.
least k square by r square will reach first, right? Time will be less because time is directly proportional to k square by r square, right? Least k square by r square will have
Yes, sir.
reach first means lowest time. Maximum k square by r square means highest time or will reach last. From this equation, you can solve the problems in exam. So equal k square by r square means will reach together.
Okay.
Okay.
Yes, sir.
So if we summarize these 3 points, velocity of rolling will be velocity of sliding, right? Root, that's what we got, right? Root 2gh. Sorry. Here, root 2gh, right? There is
Yes.
nothing but velocity while sliding, right?
Yes, sir.
Velocity of sliding by root over 1 plus k square by r square. So next, acceleration of sliding is equal to acceleration of rolling is equal to acceleration while sliding, that is g sin theta, divided by 1 plus k square by r square. Okay.
Yes, sir.
So then time of rolling is equal to time of sliding into root over 1 plus k square by r square. Got it?
Yes, sir.
Just I summarized it in comparison with sliding and rolling. The main points are these 3 equations. You can make a note out of them. What are these 3?
Yes, I wrote it.
Mostly in mains you will only ask it be you will only mains and JE, BITSAT especially BITSAT NEET exams, medical entrance exams. This comparisons only are asked. But if values are also, because they are asking, the exam time is very short, right?
Yes, sir.
Because number will be higher. For every question, the time that can be spent is lower. So in that exams, they expect you to know the answer concept, but not a huge calculation is required. Okay.
Yes, sir.
You can make note of these formulas and you can practice the problems from previous year questions and the material. Okay. So now this is the end of this lecture. Rotational motion. If there are any doubts, you can ask me after solving.
Understood, sir.